Have you heard the story of the man who may have been executed because of bad science? In December 1991, in Corsicana, a house fire tore through a small home in the early morning hours. Inside were three little girls, all under the age of 3. Their father, Cameron Todd Willingham, escaped the flames, but his daughters did not survive. What happened next would turn into one of the most controversial forensic cases in America. Investigators quickly decided the fire was not an accident. They pointed to burn patterns on the floor that looked like puddle-shaped stains. They said the fire burned unusually hot and fast. They claimed cracked windows proved an accelerant like gasoline had been used. To a jury in the early 1990s, it sounded like solid science. The fire investigators testified confidently. They used technical terms. They explained pour patterns and crazed glass. They said these were classic signs of arson. The prosecution argued that Willingham had intentionally set the fire. There was no direct eyewitness, no video, no clear confession. The case leaned heavily on forensic interpretation of the fire scene. Willingham was convicted of murder and sentenced to death. For years, he maintained his innocence. Then something unexpected happened. As time passed, the science of fire investigation began to evolve. Researchers conducted controlled burns and discovered something shocking. Many of the so-called classic signs of arson were not reliable indicators at all. What investigators once called pour patterns could actually be caused by flashover, a deadly phenomenon where a room becomes so superheated that everything ignites at once. When flashover occurs, it can create burn marks that mimic the appearance of accelerant trails. Cracked glass? That can happen in ordinary fires due to rapid temperature changes. Even low burning patterns on the floor, once considered proof of gasoline, could occur naturally when synthetic materials melt and pool. Independent fire experts re-examined Willingham's case before his execution. One expert warned that the original fire analysis had been relying on outdated methods and unproven assumptions, but the execution went forward in 2004. Years later, the Texas Forensic Science Commission reviewed the case. Experts criticized the original fire analysis as flawed and based on outdated beliefs rather than modern scientific testing. The case became a national debate, not just about guilt or innocence, but about something bigger. How many forensic techniques once treated as unquestionable science were actually built on tradition, not data? This wasn't just about one man. For decades, courts also relied heavily on bite mark comparisons, hair microscopy without DNA testing, tool mark matching without statistical validation. Some of these fields were later challenged for lacking rigorous scientific foundations. The Willingham case became a symbol of a larger problem. When science in the courtroom sounds confident, juries believe it. But confidence does not always equal accuracy. And that's what makes this story so unsettling. If the fire investigators truly believed their conclusions, if they were using what they were taught at the time, then the tragedy wasn't just the fire itself. It was that outdated science may have helped send a man to his death. To this day, debates continue about whether Cameron Todd Willingham was innocent. What's clear is that fire science changed dramatically after his conviction, and it leaves us with a haunting question. If forensic science once convinced a jury beyond reasonable doubt and later turned out to be unreliable, how many other verdicts were built on evidence that only looked like science?